Welcome back, chat. Today, before we jump into the video, I want to start with just an observation of how annoying it is for me to watch my favorite live shows from other countries around the world. I am a huge follower of anime, and unfortunately, I don't get Japanese television here at my home in the States. But there is a way that I and you can all reap the benefits of Japanese television while living in the United States of America. NordVPN allows me to set my location anywhere in the world. That makes it so I can watch what I want to watch when I want to watch. Huge shout out to this sponsor. I really hope that I don't get banned from YouTube. I don't really have a sponsorship, and I think I could probably get a cease and desist letter. We'll see if we can get it going. Hashtag Liddy. All right. Ooh, fun fact. Do you know what it's really called when you're fighting, when you're suing somebody in court? Litigation? Which is a fun variation of what hashtag Liddy could mean. Neat. All right. I don't have NordVPN. I don't use one. I don't have a need for one. Anyway, here we go. We were talking about what yesterday? Synthetic division. Now, I might have decided I hate this, and we're going to see why. This looks really blurry to you, or no? Okay, that's too big. If we go here, does that look smooth or does that look blurry to you?
It looks blurry.
It kind of looks blurry to me.
Yeah.
Does it really to you?
It does.
Okay, not a lot, just a little bit. Cool. I wish I could set that to 150. I lied. We're just going to use regular size. So here we go. The big motivation for why we're doing this, I want you to talk with your neighbors. Why care about division? Why? So the answer I'm not looking for, just so you guys are aware, is because we're in a Precalc class and that's a part of the curriculum. It's certainly valid, but from a mathematical point of view, why are we doing this? What's the motivation, the justification? Chat it out for a minute or so. I want to see what you guys think. I'm sure I've referenced it, but I don't know if it's stuck because we've never written it down. Cool. I'll give you a moment. Why?
To break things down into smaller parts.
Use the F word. We do this to factor. Now, we could just keep this going forever, right? Why do we factor? And that question depends on the context. Mathematics is one of the fields, or I guess maybe not one of them. We'll see. There are times where the mathematics that we do is for the sake of doing mathematics. You guys, my motivation, just kind of my philosophy, is I know that not all of you will be mathematicians. My hope is that maybe one of you will, or more than one of you. I didn't intend to be a mathematician when I went to college. But as we go through here, we are doing this for factoring because in any real-world situation where you model stuff, the zeros, the roots, the solutions wind up having a real-world impactful meaning, depending on what it is. If it's physics, you might look at where something strikes the ground. If it's a business sort of context, then maybe these points represent something about oh, this is how much I have to sell before I start making money or before I go broke and so forth and so on. Each individual context is going to be different, but we are dividing because we're building up our ability to factor. That's the whole motivation, kind of mathematical or very mathematical. But with that, two additional things that are going to be really awesome with this. Should we start today with another example of synthetic division, or do you feel like you're okay with it? Cool with it. All right. So moving on then. Today we only have two simple things to hit, and hopefully they're not too bad. The first of these we are going to refer to as the remainder theorem. So two theorems right now. We're not going to prove them. We could. Do you want to prove them? Okay. The remainder theorem. Now, I use THM for theorem. The remainder theorem. Okay. This one was much more important, I don't know, 50 years ago before handheld calculators were significant for us or easily accessible, but it will still wind up being helpful in this context as well. So the remainder theorem is stated as follows. If a polynomial function, and I'm just going to say if a polynomial, and then we will call it f of x. If we have a polynomial function like f of x, and I don't think I need a comma there. Grammar people, I don't think I need it, do I? if a polynomial f of x, I think that works. Weird. Okay, anyway, if we have a polynomial f of x and we divide, or is divided, by something of the form x minus k, where, gosh, that sure looks familiar from what we did yesterday, leading coefficient of 1 and a power of 1, right? If you divide this thing by x minus k, then, and here's the big takeaway, the remainder is r, which we'll call it just r for remainder, but it turns out it is exactly equal to f of k. Now, this just as it's written, maybe or maybe not, you can tell me what it's doing, but we're going to see real quick, and we're just going to use an example with the remainder theorem. So because it's embedded within, I'm not even going to bother naming it. Let's make a gross function that's bigger than we want maybe to deal with. Let's consider this lovely function f of x, and I'll give you guys a second because oftentimes I go too fast. I'm going to pause for just a moment. Cool. Can you guys do squares in your head? Like 7 squared, 8 squared, you know the basic ones, right? Can you do cubes? Maybe less than the other, right? Okay, so we're going to do this without a calculator, and we're going to see if we can't make sense of it. I want us to consider 2x to the fourth plus 3x cubed minus 5x squared plus 2. There's our function. Okay, for this, we're considering this, and I'm going to fix that too because I hate it. This is not a terrible function, but it's not super nice either. Here's what I would like us to do. I want us to evaluate without a calculator. Evaluate, and then that's where we'll jump in with it. So, let's check it out. If I wanted to evaluate f of, I don't know, what's your favorite number? 3. Okay, I'm going to make it negative. If I asked you to evaluate f of negative 3, and I didn't say anything else, could you?
Yeah.
Would it be fast?
Fast.
Like, how long do you think it would take you?
I don't know. 5 minutes.
So maybe 5 minutes. Like, yeah, probably. Now, don't write this down. If it's white, don't write for today. Could I go through and do this? That's literally how you would probably do it. Not figuratively, but literally, that's probably what you would go with. I have faith that most of you could probably do this. However, the second I throw in a negative in there, where might mess up start to happen, do you think? Dang exponents and negatives, right? Anybody know 3 to the 4th off the top of your head? Well, I know that 3 to the 3rd is 27 times 3 is 81, right? Okay, so maybe not. Is it positive or negative? It would be positive. Now, you may be able to do this. If the numbers got bigger, would it be as easy? But check it. If I want to evaluate this, this is the old way. And you can certainly use it, but I'm going to say old way, and then we're going to do this face to indicate don't like it. I think that's a face. I don't know if it's experiencing displeasure or not, but we're going to say it is. However, this right here is going to hook it up. I know that the remainder is f of k. And all I need to do is divide this thing by x minus k. So we're going to use this remainder theorem to see if it's easier than doing it like this. In this situation, what is k? F of what am I trying to find? And we're going to do this exact same problem on A. We're just not going to do it the old-fashioned way. F of what number? Okay. Did everybody know that and you were just being quiet, or was everybody kind of not sure? Holy cow. We're going to do something real quick. So as we're dealing with this, we have k equals negative 3. If we go back to this, that means if I were to plug in x minus k, what would it give me? X minus negative 3, which you changed to x, plus 3. Are you guys cool with that? All right. Now, we're going to do synthetic division real quick with this original function, and it's going to be so much easier than evaluating it out here, I promise. As we go through, let's just try it. If I'm using synthetic division, what goes outside? Negative 3. Okay, what goes on this top row first? Sean, first thing in this top right here. 2. So I'm not going to write the x to the 4th, I just like the 2. Mickey, what's next? 3. Angel, what's next? Negative 5. Abigail, what's next?
0.
Good catch. And Fern? 2. All right. Synthetic division is going to wind up giving us our answer. So I'll give you a second. I want you to run through the synthetic division, and I would call this division, but you may refer to it as synthetic substitution, just so you guys are aware. Run through it, and all I care about in the end is what's that remainder. I'll give you a moment. Now, if we go through and we get 38, do you guys agree that that is much simpler than just doing this? So what we've just found, this is my remainder r, right? The whole deal that we just did was we evaluated super duper quickly f of negative 3 and saw that it was 38. This is a huge benefit on like a time thing where you maybe don't want to spend a minute typing something into your calculator. Let's try one more. B, without all this extra work, and I'll move up so I can see the actual function because I don't remember what it was, and we'll just do it right here on our notes. Nope, I lied. Okay, doesn't matter what the actual function is, I have the numbers. Let's find f of, I don't know, let's do negative 7. Because I have no idea what 7 cubed is. Not a clue. Cool. Use your synthetic substitution is what I'll call it, and run through. I'll give you a moment. Won't use a calculator. I'm going to double check that. Wait, don't use it. Did it come out to be that?
No,
or are you
no,
just
no.
trusting me?
I just thought that you were looking for the first one. I don't think
So I want to walk you through my mental process because I started to do long multiplication, but I want to show you guys there's easier ways to do multiplication. Okay, up through the first one. Did you guys all get to 72? Like, is that the correct value, 72?
Yeah.
Okay, so as you do this, I was worried about this number and I went to reach for my calculator. Kalisha did the same thing. I don't want to use my calculator because we're trying to do this without it. I want to walk you guys through just my mental math with the understanding that it might be a little bit different. I'm not likely the fastest mental math person in this classroom, just so you guys are aware. But do you guys like it when problems are easy or hard? Like, obviously easy, right? So if you're doing, lost my train of thought. If you're doing 7 times 72, do you have an easier way to do it? Like, how did you guys do this calculation? Do you actually go over here and say 72 times 7 and then make it negative? Okay, that would work. That'd be fine. There might be an easier way, though. Do you agree that that's the same thing as doing 7 times 72? That's what we're doing, right? Is this still 7 times 72? These are much more manageable in your head if you just spend a moment and rearrange. What's 7 times 7? 49. We'll add a 0 since it's 70. Plus, what's 7 times 2? 14. And now I'm confident that it is a negative 504. Okay, I would recommend making use of that. If you're doing the same thing here, how would you multiply 7 and 504? So that'd be 54. Careful. 7 times 500 plus 4. Yeah, same thing, right? 3,500 plus 28. 35, 28, and I had a negative times a negative. That's a positive. 35, 28. Pretty sure it's 35, 30. Okay. This one took a little bit of work, right? Like, it's a little bit harder of a problem. But I want you to be really aware. If I had made you guys go into our original problem, and I'll just write the answer here. So equals 35, 30. If we had gone into this original and I made you replace everything with 7, would it have taken longer than what we just did, even with having to do it by hand with multiplication? This would have sucked, right? This is beneficial. It is an efficiency thing. Okay. Feel okay with synthetic substitution or the remainder theorem? Those are the same thing. Cool. One more topic, and I lied. It's going to be more like 30 minutes. Sorry, guys. Last one. This should go crazy fast because we've already used it, and I've referenced it. I've used the right language. Don't like that. We're just going to ignore that for now. Okay, last one. We had the remainder theorem. We get one more theorem today. The factor theorem.
Should I turn my page?
This one's pretty short. You're good. You might have an example on the other side, but I don't know. You might have a couple examples on the other side. Okay, this one I know for a fact I've discussed, but I just haven't called it a theorem. I'm going to make a claim. A polynomial. A poly, and I'm just going to write poly here, that we'll call it f of x, has x minus k as a factor if and only if there's some particular result. I have tried to stress the heck out of this one over the last couple days, and we'll see how good of a job I've done. How do you know if something is a factor, if a divisor is a factor of your dividend? So there is a remainder. I want you to change that language just a skosh. When you say there's no remainder conceptually, you got it, 100%. The remainder is 0. A polynomial f of x has x minus k as a factor if and only if, and there's a couple ways that we can write this out. And I'm going to let you pick, or you can write them all, because there's like variations of this. First one, and I'm going to keep it yellow. F of k, when you did this, what would it have to spit out at us? So it would be r, and the remainder would be what? So f of k would be equal to 0. That's one way you could word this. And we're going to write like 3 equivalent statements, and whichever one clicks in your head is the one I want you to think about, okay? All right. Alternatively, we could say, or, if you took f of x and divided it by x minus k, the remainder is what? Is 0. Okay, these two statements mean the exact same thing logically and equivalent here. They're just two different interpretations. There's another way that we could do this. We could say, or x equals k is a solution to f of x when we set it equal to what? 0. These are all the same statements. I'm going to use equiv for shorthand for equivalent. Now, in my mind, I like the second one. That's the one that feels most natural for me. But the first one is the exact same language, just through the remainder theorem. Okay, where this benefits us, and I'm going to make a follow-up comment. If, let's say x minus k is a factor, then, and if I'm going to see what you guys think of this, don't write it yet. If I write this, q of x, do you know what I'm referring to?
Quotient.
The quotient. Then q of x is also a factor. Okay. Unless it is completely prime, which normally consists, there's a bunch of different situations in which a factor could be prime. If it's linear, it's going to be a prime factor. But there's other situations. You should always look to see if you can factor further. So with that in mind, let's do a couple of, at least one problem together. And I want to find one that's ugly for us to do as a whole class. And then I'll give you a slightly easier one, and then I'm going to cut you loose. So here we go. And before I do this, I suppose, is there any part of this that somebody looks at and goes, ooh, I don't get it, or I don't like it, I don't understand? Bet. All right. I'm going to start saying wager. Cool. So example, and I'm trying to look at this. We're going to say example, and I'm just going to say use it because I'm going to write the directions on different ones. So the first of these, here's what I want us to do. I want us, on A, find all factors of the function f of x, which we'll define this time, and I'm trying to make sure I'm not doing one of your homework problems. 2x cubed, so f of x equals, 2x cubed minus 15x squared plus 27x minus 10. So there's our big ugly function. Find all factors of this given that x equals 1/2 is a root. Okay. We get this big cubic thing here that we don't know how to factor yet. As I'm looking at it, nothing nice works. Do you guys know if I try to factor this, any idea the first route I would take? So good call. You're always right if you answer GCF. After that, though, my rules don't apply. It's not a binomial, it's not a trinomial. When we group stuff, we take a trinomial and write it with how many terms instead? 4. I would try grouping. Turns out it doesn't work nicely here, but it's a good thought to have. Okay, so right off the bat, we need to make sure that we have some logical connections. And this is all like, I'm trying to think of that, like foundation stuff that I would include this time, but I wouldn't do it normally. If, and I'm not going to write if, we're just going to use the implication arrows. If I say the following, x equals 1/2 is a root, this implies something. What's a factor? Because before, because I think you were probably on the right track, I interrupted you, that's my bad. Whoever spoke, I thought it was Rafa, but maybe not. If we have a factor and a root, are they interchangeable? We had 4 equivalent statements last week, roots, factors, solutions, and zeros, right? If x equals k is a root, then what's the factor? X minus k, or x minus 1/2 in this situation. So we already know that x minus 1/2 is a factor. Now this is all just definition stuff and moving it around. A root comes directly from your ability to identify the factor. Okay, so I'm going to put a little star next to this because we're going to use it later. Here's the other thing. I want to know if this goes into it, and we can check it. We're told it does, unless I have a typo, but we'll figure it out here in a moment. If I want to find other factors, I know that the remainder, when I divide by x minus 1/2, it should be what? If I take f, that big ugly thing, and divide it by x minus 1/2, what should the remainder be? It should be 0, because we're told that it's a root. Okay, let's double check that, because we also are going to wind up needing the quotient, because we're going to have to factor it more. So I have a star next to one of them. Long division or synthetic? Good choice. What goes outside? Okay, it feels like less of a good choice, but I promise it's not going to hurt us. 1/2 goes on the outside. As I look at this, am I cool to just write all the coefficients, or am I missing anything? What do you think, Mickey? Can I just write 2, -15, 27, -10? When would I not be able to? Oh man, my ears are just super itchy and I have to look this way. I wasn't really plugging my ears. Did somebody lean and hook it up? Okay, you guys are terrible at backing up your classmates. Only time I ever have to worry about putting a 0 in there is when what's missing?
A power.
A power.
Yeah.
So I was looking right over your head. You probably couldn't tell, but that's okay. All right, I have cubed, squared, to the 1, and then a constant. I'm good. No missing powers. Now, let's hope this doesn't get awful, and we'll see. That's a 2. Baller. What's 1/2 times 2? 1. Negative 15 plus 1. Oh, thank goodness that worked out so nicely. If it doesn't work out nicely, keep it fractions. Don't change to decimals. Okay, what's half of negative 14? Negative 7. And when you add this, you get 20, I believe. I'm going to draw this bar here. What's half of 20? 10, and we add them. We get 0. Okay, now, logically, as we go through, we've just done a couple things. Right here, what have we just confirmed? We know something. And we, in fact, even got new knowledge out of the deal. So careful, your idea is there. X equals 1/2 was a root, or x minus 1/2 is a factor. But there's more. So is, what's our other factor that we get out of the deal here? Or rewording it, what was the quotient? 2x squared minus 14x plus 20. And I'm going to put parentheses around it for now. Notice, if you're struggling with this and going like, what? Here's the numbers. We just kick down a power, and we start counting down. There's where they come from. Okay, beyond this, what I typically do, I don't normally write this statement, but it's easy to forget the stuff that you've done, especially as the problems get longer. What I normally do is on my next line then, I write f of x in its factored form. One of the factors was x minus 1/2, and the other factor was this guy, 2x squared minus 14x plus 20. Right now we have 2 factors, listed at least. Okay, can you factor x minus 1/2 anymore? I'm not trying to trick you. Like, you could take out any number that you want and make it uglier, but you can't really factor it anymore. That's prime at this point. Let's deal then with this guy. So I'll make a comment here. Again, this doesn't normally get written, but it's good on at least one example. This is prime. We're done with it. We need to check more F word. That's what we're checking. So I'm not going to let x minus 1/2 leave. I'm, in a moment, when I rewrite this, because we're going to check it, I'm going to put x minus 1/2 on the other side of it, just temporarily. So let's look at this one. And the question is just, can we factor it further? So let's look. I'm going to write equals, and I lied. I'll keep it consistent here. If we're trying to factor, what's the first thing that you would do? GCF. In this, is there a GCF? What is it? Okay. Now this is going to feel weird, but I'm doing it for a very particular reason. Multiplication doesn't matter if it's a times b times c, or if you do a times c times b. You can rearrange it, right? To make this a little bit nicer, I'm going to put the 2 out here. So now we have 2 times x minus 1/2 times, and what would be left inside here? X squared plus 10, I think. Why did I move the 2 out front? To make it easier to follow, and honestly, it's purely stylistic, because in my mind, there's just something that feels wrong about it. Like, I think that looks stupid. It's the exact same thing. You're okay to do this, but I bet I wind up distributing this 2 into here anyway. Okay, let's go again then. We're going to keep looking. The 2 hangs out for the ride. My x minus 1/2, nothing else has to change unless you want to distribute it. And now we need to run through our list with this guy again. What's the leading coefficient? Love it, because it means there's a shortcut, hopefully. If you multiply 1 and 10, what do you get? 10. Can you tell me two factors that multiply to be 10 but add up to what number? What two numbers multiply to be 10 but add up to negative 7? 2 and 5 add up to positive 7. Negative 2 and negative 5? I think they both have to be negative, right? Because together they multiply to be a positive. Okay. So check it. What's negative 2 times negative 5? And what do they add up to? Negative 2 plus negative 5. Yep. So I have negative 2 and negative 5 in my head. What's the shortcut tell me what does the shortcut tell me I can do? Negative 2 and negative 5 are the magic numbers I just found. So x negative 2 or minus 2. And then what's the other one? X minus 5. We are completely factored at this point. Nothing can go further. How many factors did we find? And that can be a sneaky question. I'm not trying to trick you. So I have 4 written. I found 2 additional just now. I would claim, though, Rafa, that this, while it's not truly prime, if I just do this distribution, I can see factors with x. And that's probably what I should have asked. How many factors that are going to give roots do we have? And 3 would have been the different answer. That's how I would probably write it. Notice real quick, because this will show up later, this was a cubic, right? How many factors did we find? Interesting. How many roots are we going to wind up finding? If we had to, because this problem just said to factor. What's the multiplicity of each root? 1. They all show up one time. Okay. Is factoring starting to feel easier, or is it still just as bad? Easier? Okay. So, with that, I have a monstrosity of an assignment that I don't want to read. I'm just going to do it here. I don't think it's going to be crazy long. We get 20 minutes in class. It's a bunch of random problems, though. If you are ready, I can read it. This is homework 2.3, which will be found on page 144. And I'm going to let everybody catch up, and when you're ready, I will read all the numbers. Looks like everybody's just already writing the numbers anyway, so I won't read them. Tomorrow, I'll wait till you guys are done. I got you, Huggins. I can read them. 17, 21, 35, 38, 46, 55, 60, 67 through 73 odd, and 87 through 90. Don't lose it.
I have a eraser.
Oh, you have one now?
Yeah,
oh.
I do. Yeah.
I thought that pencil just wouldn't take one.
No, this is that was a different one.
Okay.
Yeah.
All right.
Look how much eraser I have.
Boom. Won't need it, right? Okay. I'm gonna let you guys work.